Let's go over the 2016 free response questions that I gave you yesterday, and I will also cover scoring while we do this. So we have this situation here. Notice that this is a graphing calculator problem. That is very important. And let's read. Water is pumped into a tank at a rate modeled by W of t equals this mess. Okay, that's a rate function. That's the rate at which water is being pumped in. Water is removed from the tank at a rate modeled by R of t, where R is differentiable, which we've been reviewing. That also means it's continuous, and decreasing on 0 to 8. Selected values of R of t are shown in the table above. At time 0, there are 50,000 liters of water in the tank. All right. So let's start with part A. Estimate R prime of 2. Well, keyword, I think, is estimate. They didn't say find R prime of 2. They said estimate R prime of 2. And so the derivative of a function tells me the slope of the tangent line. So here are my values of R. If I want to find R prime of t on part A, the only thing if I want to find R prime of 2, all I need to do is find slope. I need to do R of 3 minus R of 1 all over 3 minus 1. And remember, they often look for this difference quotient. Okay? So we want to see that. And then you just look at your table. R of 3 is 950 minus R of 1, which is 1190, all over 2, and you get negative 120, but they give you this little statement here. If you don't put the units in, you're going to lose a point. So it is liters per hour squared, because this is liters per hour. We took the derivative of it, so it's liters per hour squared. If you're scoring your, please score yourself as you go. You get 1 point for the correct estimate, and you need to have this difference quotient either here or here to earn that point. You will not earn it just with the negative 120. You need to have this difference quotient shown. And then you get 1 point for the units. Okay, so if you have all of that, then you've earned 2 out of the 9 points in this question. Let's go to part B. Use a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. Is this an overestimate or underestimate of the total amount of water removed? Give a reason for your answer. Well, when I talked about this problem in the Google meeting yesterday, my tip always, anytime we're doing these Riemann sum things, is to look at this thing graphically a little bit, and it actually helps us answer the overestimate, underestimate thing. So at time 0, we're up here at 1340. Then we've got 1, 2, 3, 4, 5, 6, 7, 8. But we only have information at 1, 3, 4, 5, 6, and 8. So at time 1, we're down to 1190. At time 3, we're down to 950. At time 6, we're down to 740. And at time 8, we're down to 700. And so then what we've got going on here is just triangles. And it is a left Riemann sum. So this is LRAM. So I've got a, I said triangle, I meant to say rectangle. And notice these are matched up to these values over here. So what you do have to pay attention to is the fact that the widths of these rectangles are not all the same. All right. So what do I need to see in terms of my work? Well, first off, if I'm finding the total amount of water, all right, and I'm using a rate function, then I'm technically finding an integral. Okay. The integral from 0 to 8 of r of t dt is approximately equal to adding up all of these areas. So the first one is 1 times 1340. The next one is, this width is 2, so it is 2 times 1190 plus 3 times 950 plus 2 times 740. All right. If you have that right there, you have earned 1 point. Okay, there are 3 points available on this part. You've earned 1 point for that. Then you earn another point for the correct estimate, which is 8,050 liters. And so that's 1 point. And then you earn the third point by explaining why it's an overestimate or underestimate. All you have to do to be able to do that is just connect the dots here. And you get 1 point for stating that it is an overestimate, but you have to say why. You have to state why. It's an overestimate because R of t is decreasing. Okay, let's go to part C. Part C, use your answer from part B. So we're going to use this 8,050 some way. Okay, we're going to use that some way. Use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of 8 hours. All right. Well, let's remember what's going on here. We've got water going in, we've got water going out. All right. But we also started the total. You've got to remember that we started with 50,000. So it's going to be 50,000 plus what? Well, it's going, we need to consider, okay, R is, water is removed from the tank by R of t. Okay, so that 8,050, we're going to subtract that at the end. Where did I get the 8,050? From part B. Okay. And remember, they told us to go from 0 to 8. Well, water is being added in. Okay. Water is added in by W of t. So we also need to find the total amount of water being added in by integrating the rate function for that. So we need to integrate W of t. All right. And just for having this correct statement right here, this earns you 1 point. Okay. Now, how do I calculate this? With the TI-84. Okay, this is the calculator section. So they don't expect you to waste a bunch of time. So, in case you have forgotten, we press Math 9. I've got a 0 there, I've got an 8 there, and I put the W function in here, which was 2,000 e to the negative t squared divided by 20. Now be careful putting this in. This would be negative x squared parentheses divided by 20 power. We'll do it with respect to x just to get an answer. and you get 7,836.195. 7,836.195. Rounded or truncated to 3 decimal places. So then I need to do 50,000 plus that, and I need to subtract 8,050. And when you get the final answer of 49,786 liters, that earns you the second point. Okay. Let's real quickly, briefly talk about Part D. I'm going to create ourselves some room here so I can squeeze it on this page. Part D most definitely involves the intermediate value theorem. Okay. So we must state someplace that these functions are continuous. Okay. Both this function and we're told that R of t is differentiable, so you need to state someplace that W of t and R of t are both differentiable, which means they are continuous, so the intermediate value theorem applies. All right. Now, the next thing that you've got to do, they're asking, is there a time t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? Okay. So, what we have to do is we have to look at W of 0 and W of 8, okay, and we need to compare that with R of 0 and R of 8, all right, and so at some point you must have shown that you considered W of t minus R of t. That earns 1 point. Why are we doing that? Because they're asking, is the rate at which water is pumped into the tank the same as the rate at which water is removed from the tank? Okay? And what you're going to find is that there most definitely is a place, because if you do the subtraction on these, one of them is positive, the other one is negative, and so that means it has to go through 0 by the intermediate value theorem. Okay, so that answer earns your other point, which makes the 9th point. Let's go to question 2. Question 2, I really want us to get drilled in on these velocity questions. I don't know if there's going to be one on the exam or not. There almost always is. But this is a question that we should be able to get right. Part A. At time t equals 4, is the particle speeding up or slowing down? Well, if I'm going to answer part A, I need to compare velocity and I need to compare acceleration. Because if they have the same signs, it's speeding up. Opposite signs, slowing down. So I need to do V of 4 and I need to do A of 4. Alright, and you can do that right on the graphing calculator. There's no need to do this by hand. Alright, put in your function. You can use the table input for A of t, which remember is the same thing as V prime of 4. You can use math 8. Okay, you can go straight to here and you can do math 8. Alright, d dx. Put in your function, which is 1 plus 2 sine of x squared divided by 2 and we're doing it at time 4, and you get that that is negative 0.164. This is negative 1.164. When you plug it in on V of 4, you get 2.978 truncated. So then my conclusion is, notice that my signs are opposite. This one's positive, this one's negative. So the particle is slowing down. You must state why. Because velocity and acceleration have different signs. Alright, and on this one you earn 2 points for the conclusion with your reason. Okay, if you don't have a reason, as a matter of fact, if all you have is this, there have been some years that I've been a reader where if all you have is this statement correct, you don't even need to state these values. But I will tell you, if you're going to state these values, they need to be correct. Okay? These need to be correct. If you're going to state them, they need to be correct. And if you have this statement here, you're good. Part B. Find all times t in the interval when the particle changes direction. Justify your answer. Well, it's going to change direction when v of t equals 0. Once again, you can use your graphing calculator. Alright? You can find where this thing crosses the x-axis. Make sure you're in radian mode since it's a sine function. So all you have to do is graph that function. Y equals 1 plus 2 sine of x squared divided by 2. I'm going to check my mode. I am in radian mode. I'm going to go to zoom trig, see what this thing looks like. It's kind of crazy. Alright. But notice what they said in the problem. They said between 0 and 3. So all I need to do on this thing is I need to close down my window so that all I need to see is 0 to 3. So I'm going to go negative 1 to 4. Alright. Now I'm going to graph it. Okay. Remember, let me go back to my window here. I've got my scale is confusing us here. I need to make this scale 1. Okay, here's 1, 2, 3. It only crosses once, so we can do that with the graphing calculator. Second, trace 0, and we squeeze in our 0. Remember how to do this. It shouldn't take you long. Enter, enter. 2.707. V of t equals 0. When t equals 2.707, you must justify your answer. Okay, you do get 1 point just for having this, but if you don't justify your answer, you lose the second. Okay, what do I say? I would need to say something like v of t changes from positive to negative. So it changes direction. You don't want to just say that it's equal to 0 there. You want to say that it changes from positive to negative. Part C. Find the position of the particle at time t equals 0. Well, to start with, I need to know where it's at time t equals 0. And that's right here. Alright? So I need to find out the location of the particle. Okay, so you can say that S of 4, you can say that S of 4 equals 2. Okay, and then you can say that the position is equal to 2 plus, remember that if we integrate velocity, okay, if I integrate velocity, then I get displacement, okay? So I'm going to do that, find the position of the particle at time 0. Well, I need to find out its displacement from 0 to 4, okay? And then I calculate this. Let's go back to graphing calculator. All right, so let's go to Math 9. Let's do the integral from 0 to 4 of the function, which is 1 plus 2 sine of x squared divided by 2 dx, and I get 5.8. Okay, now there is something that we have to consider here. What I have shown you is the way the AP people like to explain this problem. But there's something that we have to take into consideration here. What they did was they flipped these limits of integration, which I find very confusing. Let me show you a better way to kind of tackle this, and that's to look at this statement. The integral from 0 to 4 of v of t, remember that's going to give me the position function, s of t. And we're going to evaluate that from 0 to 4. So the integral from 0 to 4 of v of t is equal to s of 4 minus s of 0. And guess what? S of 0, this is what we're looking for. Find the position of the particle at time t equals 0. Well, I know s of 4. It's 2. And we just found this out on the graphing calculator. It's 5.815. Minus s of 0. And now if you solve this for s of 0, you subtract 2 from both sides, and you have 3.815 equals negative s of 0. So now we find out that s of 0 is negative 3.815. All right? And that is the correct answer. The problem with looking at it this way is I just think it's a little bit harder to see that we need to consider this, instead of from 0 to 4, from 4 to 0. All right, I like my way over here a little bit better, and I did confirm in the scoring that this would earn all 3 points. You get 1 point for the integral. You get 1 point for the answer, and you get 1 point for using this initial condition. So 3 points available there. Part D, I know this has been a long video, I appreciate your patience, but Part D, find the total distance. Well, on Part D, this is straight calculator. Total distance is the integral of the absolute value of velocity. Don't forget that, and you must state that. And we're going from 0 to 3. From 0 to 3. You get 1 point just for stating this right here. And then if you do that correctly, you get 5.301, which is the other point. So 1 point there and 1 point there. So hopefully that clears it up. Like I said, on this problem, on part C, I would not do it. I would not do it this way. I would do it this way just because I think it makes a lot more sense. What are we looking for? We're looking for position. So if I integrate velocity, I get position. If I plug in the values, I get the one that I'm looking for. And we'll stop the video there for today.